Time is often treated as a natural stabilizer in reliability engineering. Operate long enough, the argument goes, and individual unit performance will converge to the fleet average. This belief confuses two different things. Averaging across many units stabilizes the fleet reliability estimate. It does not stabilize any individual unit's degradation trajectory. A single system unit moving through operational time does not benefit from the law of large numbers. For a degradation process with independent increments, each operational cycle contributes its own variance to the unit's accumulated state. The variance of the unit's condition equals the sum of per-cycle variances. Over many cycles, total degradation variance grows in proportion to operational time. Neither quantity decreases with continued operation. Time adds structural uncertainty. It does not remove it. Independence of degradation increments is the mechanism. When operational cycles do not cancel each other's damage and expectation, their variances add without reduction. A system with zero mean drift still accumulates state variance at every cycle. The fleet mean condition may remain stable. The spread of individual unit trajectories does not. State uncertainty is not a temporary operational deviation. It is a structural property of degradation accumulation. Consider a fleet of units starting at the same initial condition. After one operational cycle, the range of unit conditions has 1 unit of spread. After 4 cycles, the range has doubled. After 9 cycles, it has tripled. The cone of possible unit states expands as the square root of operational time. No individual unit converges to the fleet mean in its realized trajectory. The spread grows permanently. The law of large numbers governs fleet-level reliability estimates, not individual unit states. The fleet mean degradation converges to the true population rate as fleet size grows. The individual unit's condition does not converge. A reliability engineer averaging outcomes across the fleet gets a more precise estimate of mean failure rate. The actual unit's structural state still faces growing individual variance. What stabilizes and what is at engineering risk are not the same object. Time can sharpen a fleet-level estimate of mean degradation rate. It cannot reduce the variance of an individual unit's realized operational trajectory. For any single unit following one operational history, longer service means greater accumulated structural uncertainty. The expected fleet reliability may be favorable. The individual unit's realized trajectory may not be. Time amplifies individual system exposure. It does not absorb it.